This is Unit 7, Lesson 4. What we're going to be working on today is some properties of logs. So we just learned about them, we learned what they are. Now, to go alongside those exponential properties, we're going to have a new list of logarithmic properties. Exponential properties, we have like 7 or 8 of them. There's kind of a long list. Logarithmic properties, we only have 3. So only 3 properties that you need to learn, 3 properties that you need to worry about. So we're going to start with the first one, the product property. So this one, if you have a log and then inside of the log you have some sort of product, m times n, what this does is it separates into 2 separate logs and you have addition in the middle. So it's actually kind of the perfect opposite of what the exponential one looks like. So just to remind you, so we have an exponential one that says like x to the m times x to the n is equal to x to the m plus n. So this one says 2 separate pieces with multiplication in the middle converts to 1 piece with addition on the inside. This one's the total opposite. It says 1 piece with multiplication on the inside converts to 2 separate pieces with addition in between. So we're like kind of swapping where the addition and multiplication go. And that's because logs and exponents are like total reversals of each other. So their properties work in reverse. So this is what we need to know. We're going to do a couple of these. We're going to do 2, 3, and 5 in this section. So number 2, it's in its expanded form, and we're supposed to condense. So it looks like this right now. Notice the bases are the same. So when we write it, it's still going to be that same base. So this is actually just a common log because you don't see the base written there. M and n, according to this, we have to multiply them together. So m times n would be 25 times 4, and that multiplies out to give us 100. So this is the common log of 100. Let's also do 3. All right, so this one, I did some variables. 2 separate pieces with addition in the middle means we use this property. So we're in this form right now. We need to put it into this form. So log base b, which should be 4. And then on the inside, we have m times n. So m is 2x times n, which is 4x squared. And we multiply those together for our answer. So 2x times 4x squared would be 8x to the 3rd. All right, so that's how you condense. Expanding, we'll look at number 5. So this one's a little bit interesting. We have a 45 in here, which, as you know, when you're looking at it, it's just one number, but you can expand it however you want. So there's a couple different options. What jumps to my head is thinking of 45 as 5 times 9. You might also think of 3 times 15. And I think that's it. I think those are the only choices. I wrote 5 times 9, but there are 2 possible answers here. So this is the form we're in right now. This is the form we want to turn into. So we write 2 separate pieces. We have log base 7 of the first piece, which is 5, and then plus log base 7 of the second part, which is 9. So that is the expanded version. So that's property number 1, just kind of practicing going back and forth there. So now let's look at our second property, the quotient property. If we have a single log with a quotient on the inside, it separates out to 2 logs with subtraction in between them. And again, that's just like a complete reversal of one of our exponential properties. So this we're going to do a few in this section as well. We're going to do 7, 9, and 12. So number 7, we are in this form right now. We have a log minus a log. We need to turn it into this form. So log base b, which is 3, of m over n, which is 24 over 8. In anything like this, if you can simplify, then you should. So 24 over 8 reduces down to 3. So this is log base 3 of 3. And if you were asked to evaluate that, you could, but for right now, we're just keeping them in logarithmic form. Number 9, we're in this form right now. We want to get into this form. So we have log base 4, and then in parentheses, we have m over n, so that's x to the 9th over x to the 2nd. And this can simplify as well. X to the 9th over x to the 2nd reduces down to x to the 7th, because I have a property where I subtract those exponents. So that is number 9. So that's the condensing. Let's also practice expanding with number 12. So expanding means we start in this form and we want to put it into this form. So log base b, there is no base, so that's 10, which means we don't have to write it, of m, which is the numerator, which actually is also an m, and then minus log base b, or common log, of n, and n in this case is 7. So that's what the expanded version looks like. All right, one more new property, that is the power property. So we have something that's written as an exponent like this. The power property tells me that that n that I have right here can move out front and multiply by the whole thing, acting like a coefficient. So that n from inside comes out front. So again, we're going to practice a few of these. In this section, we'll do 13, 14, and 18. So 13, we are in this expanded form right now. We want to put it into condensed form. So this n from out front comes to the inside as a power. So log base 4 of 2, and then the 5th power, according to this property right here. And then we simplify. So 2 to the 5th, if you remember from our last lesson, 2 to the 5th is 32. So we have log base 4 of 32. Again, not actually simplifying, just practicing these properties. Number 14 as well. The 7 is like the n. It gets to move inside as an exponent so that it looks like this. So with this, we have log base 2, and then m to the n would be x to the 7th. And that's your condensed version. And one last one on this page, number 18. So this is the square root of w, which doesn't immediately seem like it's an exponent, but don't forget from our last unit, square root is actually the same as having 1/2 as your exponent. So we are currently in this top form right here. We want it to be in this form, and it's a pretty quick fix. You just take this exponent, move it out front, and treat it as a coefficient. So this 1/2, we're going to move it out front, treat it like a coefficient. So that is our final answer. All right, so that gave us good practice in just trying out all of our properties. On the next page, we are going to combine a bunch of them. We're going to go back and forth doing, product and quotient, or quotient and power, power and product, just different combinations. So this is appropriately called putting it all together. All right, so we're going to do a handful of these. So in the condensing section, we're going to do 3, and then in the expanding section, we're going to do 3. All right, so we're going to start with number 21. So number 21, we are condensing into a single log. So we want to look for what properties we can use here. So the first thing I want you to see is anytime you have a value out front like this, that's always the first thing we're going to take care of. So we're in this spot right here. There's a number out front. We want it to look like this. So the 7 can move in as an exponent. So it becomes log base 4 of u to the 7th. So now it looks like this. Minus, and then we can do the exact same thing with this other piece. The 3 is like this n. It needs to come in as an exponent. So you have log base 4, and then v squared gets raised to the 3rd power. So it's like v squared, v squared, v squared. That is v to the 6th. Okay, so we took care of this property. Now, it looks like this. So we're in this form right here. We want to condense it one step further into this form. So same base, we have log base 4, and we have m over n, which would be u to the 7th over v to the 6th. And there is nothing further that we can do to simplify that. So that's your final condensed answer for number 21. We're also going to do number 23. So I mentioned if you can do this property, you always do it first. So the first thing I see is this 1/2. 1/2 needs to come in as an exponent. So when 1/2 comes in as an exponent, do not forget that what that means is that it's a square root. So the square root of 49, which hopefully we know is 7. So now it look like this. So there are 3 separate pieces. Even though our property only has 2, it works the same way. So in the inside we have m times n. This would just mean we have all 3 of these things multiplied together. So we have log base 3, and we have 4 times y times the square root of 49, which is 7. And we can clean that up one more time. So 4 times 7 is 28. So this is log base 3 of 28y. Okay, we have one more of these in this section. We'll do number 26, and then we move on to expanding. So one more time, if you can do this property, that's what you should start with. So that's what the 2 does. The 2 comes inside as an exponent on the 6. So this is just a common log of 6 squared. which we'll simplify in a second, minus common log of, and then the 1/4 moves in as an exponent on the 16. So remember what that means is it's the 4th root. The 1/4 power is the same as the 4th root. And this one doesn't have anything out front, so for now, we're just going to leave it. Okay, now for these, you might be using one or both of these. You want to make sure you always move from left to right. So left to right means we condense these two first, and that will fit with this pattern right here. So we have log base b of m divided by n. So log base 10 of 6 squared, which is 36, divided by the 4th root of 16, which is 2, and then plus log of 3. All right, so now we're using all 3 here. Now we move on to this one. So log of m plus log of n turns into a single log with m times n in the middle. So we multiply. 36 over 2 is 18. We multiply that by 3. We end up with 54. So this is the common log of 54. Okay, one final section here. We're going to do 3 in the expanding section as well. We're going to do 27, 30, and 32. So expanding, all that means is that we start off looking like this, or this, or this, and we need to expand it into this, or this, or this. All right, so we're going to do 27 first. On the inside here, you can see we have a big product. So that puts us into this category, and we need to expand it to look like this. Okay, so start with log base 6 of x, that's the first piece, and then plus log base 6 of y, and again plus log base 6 of z to the 4th. Okay, so this is completely expanded because there's no products, no quotients, no exponents. So is this one. This one is not done because it has an exponent. So that means that we're in this category right here, and it needs to be expanded like this. So the 4 plays the role of the n right here, and that needs to move out front. But just in front of this one, not in front of the whole thing, because that 4th power is only on the z. Okay, so that 4 comes out front, and then we are done. Okay, just 2 more, 30 and 32. So first thing, we've got this big exponent on the outside of everything. So one thing I might recommend is just simplifying that exponent, because we can square all this. We can have a y squared over, and then if we square this, z to the 5th times z to the 5th would be z to the 10th. That's a 2. Gets really closely confused with the z. So I would recommend doing that first. Now, with the quotient, we find ourselves needing this property right here. So m over n would be log of m minus log of n. So this one would be log of y squared minus log of z to the 10th. And finally, we take care of these exponents. So these exponents means each piece needs to bring that exponent to the front. So here the 2 comes to the front, and with this one the 10 comes to the front. So that is our fully expanded expression for number 30. And we have one final problem here, number 32. This one is a little bit tricky. So the 4th root that we have right here, that is the same thing as the 1/4 power. Okay, so I want you to think of this as having all this stuff raised to the 1/4 power. Okay, because that's what a 4th root means. So this is, sorry, this kind of blends it in with this line. This is 1 over 4. So when you have exponents raised to exponents, what you can do is multiply those exponents. So I have log base 3. M to the 5th raised to the 1/4 means I multiply the 5 and the 1/4. And I get 5/4. Then the n. 2 raised to the 1/4 means I multiply the 2 times the 1/4. And that gives me 2/4, but 2/4 is 1/2. So that's where I'm at. Now I can kind of keep this all tucked in like this. So this is a product, and because of the product, I am using this property right here. It looks like this right now, but I want it to look like this. So I do log base 3 of m to the 5/4, and then plus log base 3 of n to the 1/2. All right, one final rule here is this power property, and then we are done. So this power, the exponent, comes out front, And that's it. So the 5/4 comes out front of my log base 3 of m, plus, and then with this one, the 1/2 comes out front of my log base 3 of n. And that is our answer.